In this chapter, we're going to spend our time analyzing quadratic functions. In this lesson, we're going to look at writing the equations of quadratic functions in various forms.
Okay, hi everybody. So now what we're going to do is we're going to take a look at how to write the equations of quadratic functions. Now, it's important to know that you can have all sorts of parabolas that pass through the same vertex. Okay, yeah, it's also true of x-intercepts, by the way. You can have all sorts of parabolas that go through the same x-intercepts. So what you need to know here, and when we take a look at this diagram right here, you're going to see this. Notice that all of these parabolas have exactly the same vertex. It's the point 2, 1. So what differs from each parabola here in vertex form? What's the difference here? Well, the difference is the a value. Okay, the value that's in front of the x minus 2 squared. So here it's just the 1, and then this is that parabola right there. That's what it looks like here. Now, as soon as you put a 2 into it, notice what happens here is the arms pull in a little bit. It actually looks like it's gotten narrower. I'm going to let you know right here, actually, it didn't get narrower. What it really got was it got taller. That's just a kind of a picky little point there, but it comes in here. It's going to look narrower to most of us. Okay, when you put a negative in there, it's going to open down, and the negative 1/2. And sorry, this is the y equals negative x minus 2 squared plus 1. It goes like this. And when you plug a 1/2 into here, notice that it gets wider. And again, technically, it actually got shorter. But I would let your teacher explain that to you. It's not that big of a deal. Just as long as you understand the difference here. So you plug a fraction in there, it's going to get wider. You plug like a whole number there, a number larger than 1, it's going to get narrower. Yeah, and so the difference between all of those is going to be your a value. Now, at the same time, you can have different parabolas that have the same x-intercepts. So I can have a parabola that does this. I could have a parabola that does something like that. I could have a parabola that opens up and does the same thing, and it's all basically the same thing. Basically, what we're trying to say here is that the vertex isn't unique to a parabola. Okay, all sorts of parabolas will share the same vertex. The x-intercepts are not a unique property of a parabola. Okay, it's kind of the combination of a value and the vertex and the x-intercepts that make it unique. So basically, in most cases here, if you want to come up with the equation of a parabola, what we got to do here is find that value of a, or what we call the vertical stretch factor. And this is why I said that it makes it taller or shorter here. So if a is, or let's say the absolute value of a, if you just look for the positive value, don't worry about if it's positive or negative. You just look at the positive here. If that's greater than 1, it gets narrower, okay, or it gets taller is what I should say. And if the absolute value of a is going to be less than 1, okay, it's going to get shorter. But really what I'm saying here is this is going to get narrower and this is going to get wider. As long as you know that, we're good. So how do you do it? Well, it depends essentially on what form you're going to use, but the steps are basically the same here. If you've got the vertex, then you're going to plug the vertex into your vertex form, your h and your k. Okay. If you've got the x-intercepts, then you would plug your x-intercepts in, your m and your n, into your equation. Now, the thing then that you shouldn't know is going to be the a. So what you do is you substitute another point from the graph. But it's important that you grab an appropriate point here. There are just a couple of minor exceptions here. If you're going to use the vertex form, then you can't plug in the vertex into x and y as well as h and k. Okay, I can't plug in the vertex twice into the same equation because basically I'm not using enough information. The vertex goes in for h and k, and then I put a different point in for x and y. I don't want to put the same point in twice. I'm kind of rehashing the same old information. I'm not giving anything new. Just knowing the vertex, just think about it like this, just knowing the vertex isn't enough to make a unique parabola. I need more information. Just knowing the x-intercepts, okay, if I plug the x-intercepts in here, if I try to plug an x-intercept in for x and y there, okay, the point that correspond to the x-intercept, again, I'm reusing the same information, that's not enough for me to figure out what A is. So it's got to be a different point. Now, if I'm using vertex form, I can plug in an x-intercept into here. If I'm using the root form, I could plug the vertex in for x and y because it's a different point than the point that I'm using to build the equation. Anyway, regardless, now it'll make more sense once we see some examples here. What you're going to do is you're going to then solve for A. Then once you've got your A, you're going to plug that back into the original partial equation here. Now, I love this last little bit of information down here. I think this is so important that you have this. If you're coming up with the equation in standard form, then the variables that you should see once you've written this out completely will be the y and the x. The a, the b, and the c should all be replaced with values. But the x and the y should show up in there. They should show up in there. If all of a sudden all you've got are numbers, well then you've done it wrong. You've overdone it. Okay, you've put too much information here, and basically what you're trying to do is find a very specific point on the graph. You're going above and beyond what we're asking you to do, and you've missed it. Same thing if you're looking at vertex form. There should be numbers in for the a, the h, and the k, but you should see the x and the y showing up. In factored form, there should be numbers in for the a, the m, and the n, but there should be an x, there should be two x's, actually, and that y that show up. Okay, now let's take a look at some examples of finding the equation of a parabola. Okay, so here we go. So now we're going to determine the equation of the parabola in the form indicated. So we want to have a vertex of -4, 1 and passing through the point -3, -1 in vertex form. Okay, so vertex form looks like this. Okay, and I know the vertex. The vertex is -4, so it's going to be y is equal to a x minus -4 squared plus 1. So I can do a little bit of simplifying and get this a times x plus 4 squared plus 1. Now, the only thing I don't know in here right now is the a value. But I do have some extra information. I know that it also passes through the point -3, -1. If you do it wrong at this point here, if you substitute this in, that will give your teacher a clue right away here if how much you understand how the coordinate plane works. It's very interesting to me that sometimes that even when we get to this point here, there is a kind of I guess a separation in people's minds. They know, okay, they know that this is the x-axis, that this is the y-axis, that the point -3, -1 is -3, -1 down here. We get that. This is -3 on the x, -1 on the y. But then all of a sudden when I ask people to plug it into the equation, sometimes there's a disconnect and they don't know what's going on here. That is the x-coordinate of the point, that -3. That's the x-coordinate of the point. That -3 goes into that x. That -1 goes into that y. That's the same y. Okay? And so this should end up looking like this. And I hope that makes sense. Because frequently, and if you're in this position here, you are not alone. Frequently, people get really confused because I don't know where to put that point. This is your h and your k because it's your vertex. This is your x and your y because now it's just a point that we've pulled off of the graph here. This is a very special point. Okay, this is a more general or a specific value of a general set of points here that are on the parabola. Now what I got to do here is I got to figure out what a is. Now this is basically just following order of operations. So I'm going to do what's inside the parentheses here first. So I've got this -1 is equal to a multiplied by, well, -3 plus 4 is going to give me 1 squared plus 1. And 1 squared is just 1 multiplied by a. So that's going to be just a plus 1. Now frequently I'll see people that want to do this. They want to add those two numbers together, but I can't. Because they're not like terms. There's a variable here, there isn't an a variable here. But now what I would do is I would subtract the 1 from both sides, and you'll get a is equal to -2. And so now I can plug that in, and I get -2 x plus 4 squared plus 1. I can take this and plug it back into this form of the equation, because in this form of the equation I had almost everything I needed except for the a value. Now I know the a value, and there we go, I'm done. Okay, let's do it in this one. I'm giving you the vertex. giving you a y-intercept of 3. Now let's make sure that we know what that is. When I give you the y-intercept of 3, that's this point right here. The x-coordinate is 0, the y value is 3. I want this in standard form. Well, we've talked about this. The standard form is not the easy one to graph, okay? Which means going from information from the graph back to standard form is also not going to be direct, nice and easy here. So what I'm going to do here is I'm going to go through the vertex form, okay? I'm going to do it this way first here. Now, I know h in my k. That is going to be x minus 1 squared minus 1, okay, plugging in my h and my k. And now, just like we talked about before here, this is my x, this is my y. So I'm going to plug that point in, and I will get 3 is equal to a multiplied by 0 minus 1 squared minus 1. I'm going to go through the order of operations. 0 minus 1 is going to be negative 1 squared minus 1. And again, I'm going to do the bracket, sorry, the exponent here on this. I'm going to deal with this first. Negative 1 squared is just 1. Multiplied by a is just a. So this is going to be 3 is equal to a minus 1. And when I bring that 1 over, I'm going to get that a is equal to 4. I'm just going to add the 1 to both sides, okay? Because in order to get rid of that negative 1 on this side, I need to add a 1. Now, that means that my equation is going to be y equals 4 x minus 1 squared minus 1. Now that's in vertex form, it's not in standard form, so I need to expand that out. Remember that you should probably write that out as x minus 1 times x minus 1, subtract 1 at the end here. We should probably do this, if we're going to do this correctly here, if we want to make sure that we don't make some pretty simple, pretty predictable mistakes here, we're going to write it out like this. And I'm going to multiply out the binomials here first. So it's going to be x squared minus x negative x plus 1. Now that is still being multiplied by the 4. So that's why I have the brackets here, the parentheses. I need to multiply this product by 4 before I go to that negative 1 here, the subtraction. Still got to simplify this though. And remember, if you're wondering where that negative x is coming from, it's because I distribute the x to both terms here, then I distribute the negative 1 to both terms there. And now I get y equals 4 x squared minus 2x plus 1. And now I'm going to distribute the 4 to each term inside there. So y is going to equal 4x squared minus 8x plus 4 minus 1 at the end there. And now I just group together the like terms. Now, there's a lot going on here. But I get 4x squared minus 8x plus 3. Okay? Had to do a bunch here, but I'm hoping that it's pretty straightforward, that you understand at least the pattern of what I'm doing and why I'm doing it. Okay? In the order that we're doing it in. Let's take a look at this one. Congruent to, which has the same stretcher a value, and it's important that you catch that. That's going to be a word that we're going to assume that you know at this point here. When we use the word congruent, it means it has the same size, same shape. Specifically in this chapter, what that means is that the a value is the same. Now, it could be positive or negative, because all that's going to do for a parabola is determine whether it opens up or down. Okay, that's fine. But in this case right here, what we need to do here is just make sure that the 2 shows up here. Actually, in fact, look at this. And passing through a maximum point. Now, as soon as I say it's got a maximum point, what I'm telling you here is that the a value is negative. It's got to be less than 0 because it's got to open down so that the vertex is a maximum. And in fact, the maximum point, when I say that, when this is the maximum point, that's because that's the vertex. So there's my h and my k. So I know, just based on this, without even doing a whole bunch of work here, that my a value has to be 2, and because it's a maximum, it's got to be negative. And then I know that my vertex is the point 2, negative 3. Well, this is awesome. I can just write the equation. It's going to be y equals, negative 2, x minus 2 squared minus 3. Hopefully you can see the negative 2 there. That's it. Done. Now let's take a look at this one. The axis of symmetry at x minus 4 equals 0. Oh, okay, wait a minute. That means x is equal to 4. And now I know that that is going to be equal to my h value on the vertex, because I know that the axis of symmetry goes through the vertex. So that's what I'm trying to say to you without being explicit about it. It's got a maximum value of 6. Now, when I say maximum value, what am I saying? Well, I'm telling you that the k value is 6. And by the way, when I say that it's a maximum, I'm also telling you that the a value is negative. The parabola's got to open down. So right away there, I know a bunch about this. I know that my vertex is the point 4, 6, and I know that my a value is negative. I've got a y-intercept of -2. Oh, I just noticed something. I'm going to finish this question, and I'm going to go back and finish the question that I should have done a couple seconds ago. Just let me finish this question here. So the y-intercept here, when I give you the y-intercept here, it's probably helpful to write it out as a point there. I want this equation in vertex form, so I want y is equal to a x minus h squared plus k. Okay? So now I'm going to plug in my vertex. Y is equal to a x minus 4 squared plus 6. Now I'm going to plug in that extra point that I've got, that y-intercept here. So -2 is going to equal a 0 minus 4 squared plus 6. Now I just solve for a. So I'm going to do what's inside the brackets here, simplify that. 0 minus 4, it's just going to be -4 squared plus 6. That is going to be a times 16 plus 6. Now I need to get the a by itself, so I'm going to move the 6 over. I'm going to subtract it from both sides. And so when you subtract the 6 from both sides, you're going to get -8 is equal to a multiplied by 16. And when you get to a situation like this, I need you really to be careful about this. Very, very common mistake would be to say that a is equal to -2 here. It happens all the time, okay? It's not -2. I have to divide both sides by 16, not 8. You're actually going to get -1/2 when you divide both sides of this equation by 16. And so then I can plug that back in, make it -1/2 x minus 4 squared plus 6. It's really common that people will do this incorrectly here. It's almost like there's such a resistance to having to work with fractions that people will just automatically, without even thinking, just see 8, 16, 2. Okay, and they'll do the division in the wrong direction. Please be careful about that. Okay, now before I go on, I got to go back. I'm sorry, I didn't read that carefully here. This is supposed to be in standard form. So, in spite of the fact that I could get the equation really quickly, that's not the form of the equation that I want. So I need to write this out again and expand it out. Once again, I'm going to worry about this first. So this will be -2. X times x is x squared. X times -2, -2x. -2 times x, -2x. -2 times -2, positive 4. Now, this is still being multiplied by the -2, so now I'm going to distribute the -2 through. So y will equal -2x squared. And actually, I should have put those together first here. This is going to be -4x multiplied by -2, so positive 8x. Minus 8 minus 3. And so y is equal to -2x squared plus 8x minus 11. Sorry about missing that. That's the equation that we were looking for. Now, we're going to find, it's going to focus here, find the equation of a parabola with a vertex of 3, -1 and x-intercept of 2 and 4 in standard form. Okay, I could do this in two different ways here, and I will get the same answer, and maybe I almost should do it in two different ways here. First of all, we could do this in vertex form. Okay, x minus h squared plus k. I could plug that in. I'll get y is equal to a x minus 3 squared minus 1. And then I could plug in one of my two x-intercepts, because remember, this will be the points 2, 0 and 4, 0. It shouldn't matter which x-intercept I use. So I'm lazy, let's use the smaller number here. So 0 is going to equal a 2 minus 3 squared minus 1. Now, 2 minus 3, 0 is equal to a. 2 minus 3 is going to be -1 squared minus 1. Now, watch what would happen. If I had used the point 4, 0 and plugged 4 into this, 4 minus 3 would be positive 1 squared. And either way, regardless of which of those you use, I'm going to get positive 1 times a. So a minus 1 is equal to 0. A is equal to 1. And so therefore my equation is going to be y is equal to 1 times x minus 3 squared minus 1. I want it in standard form, so I'm going to multiply that out. I'm going to square it. This will be x squared minus 3x plus 9 minus 1. So y is equal to x squared minus 6x plus 8. Now, just to show you that this will work either way, let's work from root form. So that's a times x minus m, x minus n. So if I plug in now the x-intercepts here, I will get x minus 2, x minus 4. Now, I can plug the vertex into this because I'm not reusing the same points. I can't plug the x-intercepts in, okay, because I'm doing this in root form. But I could plug the vertex in. So I could plug the vertex and make the y negative 1 and make the x equal to 3. Now, these are both the same x, so both of those are going to get replaced by a 3. Okay, it's not just the one x. The fact that x shows up twice there is irrelevant. It's the same variable we're talking about there. And so now, what do we got here? 3 minus 2 is 1. 3 minus 4 is negative 1. 1 times negative 1 is negative 1. And when you divide, we'll get that once again, a is equal to 1. So now I can write that y is equal to 1 times x minus 2, x minus 4. And when you expand that out, I'll get x squared minus 4x minus 2x plus 8. Or y is equal to x squared minus 6x plus 8. It's the exact same equation regardless of which direction I go. Okay, so just to let you know that you got some options there. Now, let's talk about this one right here. Sometimes the graph throws people off. But you should know that I've given you the vertex here. So, and I want this in vertex form. Well, I already know, because I can see it, what the vertex is. So this is going to be a multiplied by x minus negative 1 squared plus 2. And I'll simplify that. X plus 1 squared plus 2. And then I'm given this extra point here, this negative 3 comma 1. So I'll plug that in. The y is 1. Negative 3 plus 1 squared plus 2. Okay, well now we have to do a little bit of math here. Negative 3 plus 1 be negative 2 squared plus 2, and then I'm going to do this squaring first. So that'll be a multiplied by 4 plus 2. You cannot add the 4 and the 2 together. Okay? You can't. Because the 4 is being multiplied by the a, that would have to happen first. And since I don't know what the a is, I can't do that first. But it turns out that's okay, because I want to solve for a. So really what I want to do is I want to get rid of this plus 2. I'm going to subtract 2 from both sides. And then I'm going to divide by that 4 to get a by itself. And I get a is equal to negative 1/4. So now I can write my equation. Y is equal to negative 1/4 x plus 1 squared plus 2. And actually that makes perfect sense. I can see right now that the parabola opens down. I knew that my a value should have been a negative. Awesome. And now, finally, I want to find the equation that has x-intercepts negative 2 and 3 that passes to the point negative 1, negative 8 in factored form. So I wanted an x minus m, x minus n. So I will plug those in. X minus negative 2, x minus 3. Okay, notice that there's supposed to be a subtraction in this form. So when I see an x-intercept that's negative, I'm subtracting the negative, and so now I'll take a step here and I will simplify that, make that x plus 2, x minus 3. And now I'll plug in the point. So the y-coordinate was negative 8. The x-coordinate is negative 1. Remember, that's going to replace both the instances of x that I see here. All right. Now it's just arithmetic. Negative 1 plus 2 is 1. Negative 1 minus 3 is negative 4. And so this is going to be negative 8 is equal to a multiplied by negative 4. And now I'll divide both sides by negative 4. The negatives will cancel and I'll be left with 2 is equal to a. So there's my stretch value. So y is equal to 2, x plus 2, x minus 3. That's the equation I'm looking for. Okay, so I hope after doing this a whole bunch of times that it makes sense what we're doing, and it also makes sense how we're leaving the equation. Notice that every time we did this, here, here, and then the other questions up here, there's always an x and a y. Okay, it's always y equals number with x's in there every time, okay? That's how we want you to finish it. We need to see the independent variable and the dependent variable in there, the relationship between the two. Okay, I hope that makes sense.